Okay, hi there. This is our 100N Condensate 5 video. This will be the last of the condensate systems. Most of this was in the 184N powerhouse building. Basic flow diagram. You had your 6 drive turbines in 109, and you also had the high level return to condensate 3. If the storage tank got too high, you'd send the water to condensate 3 back to the after heat removal tank. The water from all the drive turbines came up here through a 12-inch line and fed the deaerator. This took out the oxygen and non-condensable gases out of the condensate. From here it dropped down to the storage tank. Storage tank would feed the boiler feed pumps. There are 3 of them. These provided feed water to the 184N boilers and also back to condensate 2 and 109. You had your steam turbine. It exhausts steam, went down to the surface condenser. Condensate here went to the condensate pump. It went through the inner condenser tubes and the after condenser tubes, and then back up to the deaerator. Some of the component parts of this, you had your deaerator. Purpose of this was to remove the oxygen out of the water and any non-condensable gases. Anytime you have a vacuum, there's a chance of air leakage from all your turbines. The parts of this, you had a water box on top, then you had like 56 spray nozzles. These were to break the water into thin sheets to get maximum exposure between the water and steam. So this would be where the water would end up. It'd spray out and hit the tray section. These trays were real thin and the water would spill over them. You want to get maximum surface area between the water and the steam for maximum deaeration. So the steam was brought in a 15 psi G, come off the inner building header. So the steam would be all around here. This was actually a stainless steel box the deaerator part sat in. So the steam would come up through the bottom, through the trays, through the spray nozzles. Then any non-condensable gases were vented out. I believe these had an orifice in them too, and also a valve, probably a bypass valve too for startup. The drawings show there was a vent condenser. I really don't have anything on them. I know a lot of them did. You want just a slight amount of steam come out of the vents, not blowing. If you don't have any steam coming at all, you're probably not venting. And if you also had high O2. The O2 is checked down here. They had a sample line that came off. You had your normal makeup with secondary loop makeup, 4-inch line that'd feed it. Then there's a backup from the after heat removal pumps. I remember being shown a valve up here on top of the deaerator, the first thing I learned in the powerhouse, and something happened, I'd run up there and open that valve if we had to have it. I was up a few flights of stairs. From here, the water dropped down to the storage tank, held 15,500 gallons. He's about 12 inches from the top. Had an anti-flash device down here. So it's 36 feet down to the top of the boiler feed pumps. This combined with the 15 pounds pressure provided a little bit of net positive suction head so the water wasn't flashing to steam down here. There was a line coming up the 109 after removal pumps that feed here in case deaerator was taken out of service, but I don't know if this is ever used. Your boiler feed pumps, there's 3 of them. They're rated 1,300 gallons a minute, 1,720 foot head, 800 horsepower, 3-stage pump. They required 130 gallons a minute recirculation for pump cooling. This was an automatic valve here. From here, the water went to the 184N boilers and back to the condensate 2 header through the condensate valve, the 243s. Your turbine generator, I would sit up here on the, right outside the control room in the 184 building. The surface condenser was designed for 272,000 pounds of steam an hour. Required 18,500 gallons a minute of cooling. I believe we ran around 27,000. I can't remember, that number sticks in my head. There's 3,580 7/8-inch OD 18 BWG Admiralty metal tubes in this. It was 30'6" long, 19'6" high, and 11 foot wide. There's 18,000 square feet of surface area. The way this was laid out is, I remember where the condensate pump sat. The water would come in the backside, so we're looking at the water box return part of this. The water would come in this set of tubes and be coming out towards us. It'd flip around and go back, and then this would be your outlet on the water box side. They had a vacuum pump on the water box. You have a tendency to build up air in here as the water is under lower pressure. This outlet went to seal well number 2. So it's actually pulling a siphon effect on this, so the pressure is a little bit less than atmospheric. That just increases the efficiency of the cooling water system. So your circ water pumps don't have to pump water up quite as high. But anyhow, air to get dropped out, so there's a vacuum pump that keep the air out from airlocking your tubes. This red line's kind of dividing the level of the raw water. It could come through and then went back. This blue area is the tube section. They had an air cooler section in here. A lot of surface condensers, seems like they build air up in the middle of them. So they had like an air lane in the middle. They went down through an air cooler section. Then any non-condensable gases would go back. Here you had a hogging injector that you would use for startup with. This is real similar to the 109N drive turbines. They went to the inner condenser. The condensate from here is returned through a loop seal back to the surface condenser. Then your after condenser, steam jet air ejector pulled off of that. Condensate from this went through a trap and then back. So this here is how they got rid of the air out of the surface condenser. These also provided quite a bit of deaeration. To get in the water out of here, it dropped down to your condensate pump. It was a 690 gallon per minute pump, 3-stage turbine, 216 foot head, a 60 horsepower motor on it. The drawings show it was 10 foot below the floor, the bottom well. Some of these I've seen, they actually went down 33 feet or so. That way you might be almost zero here, then down at the bottom there's your back to atmospheric pressure. So you've gained, the weight of the water brings back the pressure up, so it has a positive suction. But from here it fed through the tubes of the inner condenser, then it went through the tubes of the after condenser, then from there it went to a level control valve to maintain level in your surface condenser, and then it went back up to the deaerator. Remember a recirc valve? I think there's an automatic valve here. I think we use the manual valve mostly for low loads. I'm not sure why, but I know low loads, I believe we'd use the manual valve to maintain flow through this. You have to have flow through your steam jet air ejector condensers, otherwise they won't pull vacuum anymore. To start the pump up, use secondary loop makeup water, provided water to the seal. I don't know if this is packing or mechanical seal. Could have been either, but you have to have seal water to keep air from getting sucked in past the shaft. When the pump is running, it comes off the discharge of the pump, and that provides the seal water. There's also a line went to the vacuum pump gland exhauster. This was for all the sealing steam on the turbine. Just some interesting information on this. 1 pound of steam occupies 350 cubic feet. So you can see the volume of steam coming through this thing is really pretty amazing. You know, it'd come down into here and they had a steam passage in the middle to try and force the steam into the tubes. I'd be surprised there weren't lanes cut into these to get more steam in to the tubes. I don't know, the prints really don't show it. They just show the tube set like this, air cooler section, some baffles in it. I'm sure they had plates across this for stabilizing the tubes. But at 2 inches of mercury, which is probably around a little bit lower than that, but 2 is a reasonable number. It's 0.982 pounds per square inch absolute. Water would boil at 101 degrees. So your steam coming in here is a little over 100 degrees, maybe 102, 103 degrees coming out of your low pressure turbine last stage. And it is condensed At 101 degrees, the steam will convert to water. Likewise, 101 degrees, the water will flash back to steam. So the boiling point down here is about 101 degrees in this. That's kind of an important point on these. Even though the water is cool, by our standards, inside here it's boiling. One of the problems with vacuum surface condensers like this, you're pumping boiling water from 32 foot below the pump. So you have like minus 14 pounds pressure here. Comes up around 30 feet or so, 31 feet. The water's boiling. If you're trying to pump water 32 feet up, it'd be impossible. So that's why you have to try and maintain the pressure here, same as here, so it sees the weight of the water. That's why there's a vent line to move any non-condensable gases back here. So this is actually seeing the same pressures inside here. It doesn't care about atmospheric pressure. And then the 10 foot down, it helps build a little bit of net positive suction head and raises the boiling point of the water. So after you went through the first stage, pump, impeller, you'd be back up above atmospheric, you'd be fine. This was a different style in the drive turbines in 109. The pump sat up here, and they had a line that went back to the first stage suction. Whereas these are more of a deep welled turbine pump in here. But a lot of the other stuff seems to be the same. As far as I know, this is pretty accurate information. This is the best information we have with our prints and drawings and things. Anybody has any more stuff to add to this or things, we'd sure like it. Like I say, this is just kind of our scratch paper, a rough sheet of how things work, just trying to preserve how it worked. And I'm putting everything down on a board so it kind of all fits together. After this, we're probably going to start the steam systems. And hope this wasn't too boring, but we combined a lot of stuff in the 184 and Condensate 5 because it's kind of a smaller system. This is the slideshow for Condensate 5. I'd say most of this was in the 184 building. Just some of the specs on the turbine generator surface condenser. A lot of this we had on the whiteboard. This was the drive turbine condensate pumps. I don't know if we showed this in Condensate 4 or not, but we threw it back in here. If you're interested, you can stop the video and read this. This is the surface condenser. These were the tube banks. They're drawn out in blue on the whiteboard. This was where the water box sealed, so you'd have your inlet come down the bottom and outlet come down the top. Made it 2 passes through here. This would be the steam from the turbine generator dropping down. They had a central steam lane to try to get all the steam in contact with the tubes they can. Down here was the hot well. This is kind of a physical drawing of it. This would be on the back wall looking towards the Foster Wheeler boiler. That's the inlet line, return line, water box doors. Condensate pumps would sit over here. This is the surface condenser pump. 3-stage turbine well style pump. Suction from the hot well, dropping around the outside. It's picked up down here is your suction. Discharge here. It had packing in it. At first you'd use secondary loop makeup water to seal the packing. When you start this up, start pulling the vacuum, it could suck air in, so it was on the discharge pressure side, so normally it would self-seal itself. Here's the discharge line. This is inside the deaerator. The part that we would see would be the deaerator enclosure, the pressure shell on the outside. Inside of it, you'd go through the manway door. Then inside here, you'd have your access door for all the trays. Spray nozzle sat up here. This would be the water chamber part. So you could probably get underneath these. The bigger ones, you can go crawl underneath these things and inspect them. You can do a lot of damage to trays if you water hammer them or if there's an upset condition. They did have hold down bars and stuff on them. This is the air extraction system. This just shows the air extraction on the raw water return on the surface condenser to keep from airlocking it. It took off a little slipstream. Vacuum pumps pulled on the surge tank. Anybody has any information on this, let us know. Not too sure on this. I do believe it was used. These are the two condensate pumps. This is the air extraction line. Steam jet air ejectors went to the inner condenser. From there, steam jet air ejector pulled the aft condenser, went out to an air meter. You could use this to see how much air and leakage you were having. And then it went to the atmosphere. And that's about it for the pictures and drawings we have on this. Have a good day.